Good morning, dear students. Today I will discuss about the Carnot and Otto cycle and their efficiency derivation. This is the part of Unit 5 and subject name is the Basic Mechanical Engineering. Semester is first. This is the outline of the today lecture. A review of the Carnot cycle, reversible engine, the Carnot cycle, review the ideal gas law, review about the thermodynamic process, review about the properties of air, air standard assumptions, terminology for the reciprocating device, Otto cycle, introduction and the derivation. This is the Carnot cycle already discussed in the class. The Carnot cycle was first introduced as the most efficient heat engine that operate between the two fixed temperature limit, that is the highest temperature and the lowest temperature. Highest temperature that is called the TH and the lowest temperature that is called the TL. The thermal efficiency of the Carnot cycle, it is dependent by the, it is already discussed in the class, that is the 1 minus of the lowest temperature upon the highest temperature. जो Carnot cycle की thermal efficiency है या any engine having the thermal efficiency, it is depending on the output upon the input. तो आउटपुट दैट इज अपॉन दैट इज कॉल्ड द नेट वर्क डन. आउटपुट क्या है अपने पास, जितना नेट वर्क डन है वो होता है, और इनपुट क्या है, कितनी हीट सप्लाई की गई है. तो दैट इज द वर्क आउटपुट विच इज डिफरेंसेस ऑफ द हाईएस्ट टेम्परेचर माइनस ऑफ द लोएस्ट टेम्परेचर, एंड द हीट सप्लाई विच इज द डन एट द हाईएस्ट टेम्परेचर दैट इज कॉल्ड द TH. So total that is the thermal efficiency, it is of the Carnot cycle 1 minus of the lowest temperature upon the highest temperature. तो जब डेरिवेशन उसका परफॉर्म करते हैं तो उसके बेस पे अपना पास जो थर्मल एफिशिएंसी का फार्मूला रहता है दैट इज द नेट वर्क डन अपॉन द हीट सप्लाई निकल के आता है फार्मूला. This is the PV diagram for the Carnot cycle in which the four process already discussed in the class is describing in this PV diagram. The AB is called the isothermal expansion, BC is called isentropic expansion, CD is called isothermal compression, DA is the adiabatic or the isentropic process of the compression. So these are the four processes consisting and makes in a cycle. The stage one that is called isothermal expansion at a temperature T2, while the entropy rise from the S1 to S2. So there it is the heat supplying, it is in this process it is taking place where the heat supplying taking place of the source body, and the entropy will goes on the increasing manner, and the heat entering into the system which is describing by the Q2 is equal to the T2 S2 minus of the S1, or it is already known as that in the class where the heat is supplying from the source body system, that is describing the total heat transfer is equal to the total work transfer because of the isothermal process consisting of the, there is no change of the internal energy. Stage 2 where it is called the isentropic process or adiabatic process, where the temperature will decrease because of the isentropic process and the entropy remains the constant. No heat enter from the surrounding to system and no heat leave from the system to surrounding. It is taking place of the B to C process. Third process C to D where the isothermal compression, it is taking place where the pressure and temperature will both not increase, but pressure increase and the temperature will remains the constant, and the heat is reaction to the taking place of the surrounding body. It is called the sink body where the entropy will goes on the decreasing, and the heat leaving the system that is called the Q1 is equal to the T1 into the bracket of S2 minus of the S1. That is the formula of the stage 3 where it is called isothermal compression process. Stage 4, which is called a D to A process, this is the isentropic process, isentropic compression of the air. It is taking place where the entropy will goes on the increasing because of the there it is called constant entropy process. Not entropy goes on the increasing, but temperature will rise from the T1 to T2, and the thermal efficiency formula which is obtained from the after the derivation, that is called the 1 minus of the T1 upon the T2. There is a T1 is the lowest temperature and T2 is the highest temperature. तो T1 जो है lowest temperature है, T2 जो है highest temperature है. तो डेरिवेशन करने पे जैसा कि हमने फार्मूला बताया था कि नेट वर्क डन अपॉन द हीट सप्लाई होती है, तो नेट वर्क डन आपका जो है हाईएस्ट टेम्परेचर लिमिट और लोएस्ट टेम्परेचर लिमिट का डिफरेंसेस होता है, ये निकल के भी आता है, और हीट जो सप्लाई हो रही है वो हाईएस्ट टेम्परेचर पूरी, दैट इज कॉल्ड T2. The ideal gas equation already discussed in the class. It is called a PV is equal to RT for the where the specific volume in the meter cube per kg. If the specific volume is it is in meter cube, that is called a PV is equal to MRT, where the P is called the pressure, V is the volume, M is the mass of the air or the gas, R is the characteristic gas constant and the T is the temperature in Kelvin. The internal energy and the change of enthalpy of the ideal gas can be expressed. It is a constant formula that is called a delta U is equal to the U2 minus of U1 is equal to the CV T2 minus of T1, where the mass is equal to taking of the 1 kg, and the delta H is equal to H2 minus of H1 is equal to Cp T2 minus of T1. This is another formula for the change of enthalpy. डेल्टा यू कांस्टेंट वॉल्यूम प्रोसेस के लिए अप्लाई होती है, डेल्टा एच जो कि चेंज ऑफ एंथैल्पी है वो कांस्टेंट प्रेशर प्रोसेस के लिए अप्लाई होती है. These are the thermodynamic process. It is a reviewing because of the in the thermodynamic chapter it is already discussed the isochoric process because it is called the constant volume process also, where the volume remains the constant during the heating or the cooling of the gas, and the result of the ideal gas law, that is it in short form IGL. This is the formula P1 upon T1 is equal to P2 upon T2. So this is the formula. It is obtained from the, that is called a PV upon T. It is constant. This is called the ideal gas law. And if we putting P1 upon T1 is equal to P2 V2 upon T2, there it is a chances of where the constant volume V1 and V2 are cancelled out, and the P1 upon T1 is equal to P2 upon T2. This is the formula which is obtained of the isochoric process. Similarly, on the all the other process, this is called the isobaric process, where the constant pressure remains the constant during the heating or the cooling. The volume and temperature with is a respectable manner, and the here it is called this is called air proportional, that is called a V1 upon T1 is equal to V2 upon T2. Isothermal process where the temperature remaining the constant, it is called a PV is equal to C also process called P1 V1 is equal to P2 V2, and the polytropic process where the neither parameter is a constant, but the relationship it is a manner, it is the P1 upon P2 to the power of is equal to V2 upon V1 to the power of n is equal to T1 upon T2 to the power of n upon n minus 1. This is the polytropic process fundamental formulas which are using in the polytropic process where it is used. Isentropic process जहाँ की entropy constant रहती है, it is the formula of S1 is equal to S2 because of the heat transfer is zero, no heat enter from the surrounding to system and the no heat leaving from the system to surrounding. When the heat transfer is zero, there is a no change of the entropy. It means entropy remains the constant, and the process is called the constant entropy process. There it is called the S1 is equal to S2. This is the review of the properties of air, where the R is equal to 0.2871 kilojoule per kg per degree Kelvin, CV is equal to 1.005 kilojoule per kg per degree Kelvin, and CV is equal to 0.718 kilojoule per kg per degree Kelvin, and K or gamma is equal to 1.4. It is the constant value which are taking for the properties of air, and this is are the standard values, where R is equal to ideal gas constant, जो कि ideal gas constant कहलाता है, and the Cp is equal to specific heat at a constant pressure. Cv is the specific heat at a constant volume. K or gamma is equal to called the specific heat ratio, that is the Cp by Cv. इन दोनों का जो रेशियो है ये आपका गामा या K कहलाता है. Move to the next slide. This is the example where the IC engine combustion of the fuel take place inside of the engine cylinder. It is called the IC engine. Air standard engine. Before going on the derivation for the Otto cycle, some standard assumption we are taking. Air continuously circulated in the closed loop, always behave as an ideal gas. जो भी air use की आ रही है वो as a closed loop में हो रही है, कहीं air बाहर नहीं आ रही है. और दूसरा air का जो behavior वो ideal gas की तरह काम कर रहा है. जितनी प्रोसेस यूज की जा रही वो इंटरनली रिवर्सिबल है. जितना भी कंबशन प्रोसेस इस्तेमाल कर रहे हैं उसमें हीट एडिशन जो हो रहा है वो सोर्स बॉडी के द्वारा हो रहा है. सोर्स बॉडी से हीट सप्लाई हो रही है. इट इज द हीट सप्लाई फ्रॉम द सोर्स बॉडी एंड द हीट रिएक्शन इट इज टेकिंग प्लेस ऑफ द सिंक बॉडी. तो एयर एंड फ्यूल विच इज सप्लाइड टू द कंबशन चेम्बर, इट इज सप्लाइंग फ्रॉम द कार्बोरेटर साइड. combustion product which is obtained here, it is in the gas form, and the leaving from the this section, it is going to the sink body. It is called the atmosphere. It is called a sink body. A heat reaction process that is restore the working fluid, which is the initial state, replace the exhaust process, and the cold air standard assumption apply when the working fluid is in the air and the constant specific evaluated at the room temperature, that is called of 25 degrees centigrade or the 77 degree Fahrenheit. No chemical reaction taking place in the engine during that process. This is the terminology used for the reciprocating devices: top dead center, bottom dead center, stroke, bore, intake valve, exhaust valve, clearance volume, displacement volume, compression ratio, and the mean effective pressure, already discussed in the class. So it is again here repeated. TDC, where the piston is at the topmost condition, that is called a TDC, top dead center, and where the piston is the extremely lowest condition, that is called a BDC, bottom dead condition. Intake valve, where the mixture is supplying in the engine cylinder. Exhaust valve, where the exhaust gases is circulate into the atmosphere after the working, and this is called a bore, cylinder diameter, and the stroke length when the piston is moving from the TDC to BDC or BDC to the TDC, that is called a one stroke length. Displacement volume, where the piston is moving from the one center to the another center, that is called a displacement volume. Clearance volume, where the piston is at the topmost condition and the no touching it is taking place of the cylinder head to the cylinder piston, then that is space where it is occurring, and the volume where it is the clearance space is remaining, it is called the clearance volume. तो जितना भी यहाँ पे गैप रहता है और उस गैप में जितना भी वॉल्यूम रहता है मिक्सचर का, that is called a clearance volume. The compression ratio, that is called the R of an engine, that is defined as compression ratio is equal to maximum volume upon the minimum volume. This is the maximum volume. V1, it is called a V1, and the V2, this is the minimum volume, and the volume at the BDC condition, that is called the maximum volume, and the minimum volume, that is called the volume which is are occurring at the topmost condition, that is called a TDC. The mean effective pressure, which is the frictional pressure difference, and it is operated on the piston during the entire power stroke, would produce the same amount of the net work done as that produced during the actual cycle. The mean effective pressure, it is the effective pressure value which are operating in the engine cylinder when the piston is working, and the different stroke on the different process, this is called the mean effective pressure, on which the all the things are the calculated in the mathematically form, where mean effective pressure, it is the ratio of the net work done during the cycle, and the V maximum minus of the V minimum, that is the ratio of the stroke volume, is equal to net work done during the cycle, and the maximum volume minus of the minimum volume, that is the difference of the volume. It is called the stroke volume or the displacement volume. So W net already can be written. It is also mean effective pressure into the change of the volume, that is the V maximum minus of the V minimum. This is the Otto cycle, where all the four processes are taking place: compression, power, exhaust, and the intake. Intake, where the intake valve is open. Here it is already working or the clear in the diagram. Intake stroke, first is the intake stroke, and the piston is moving from the TDC to BDC. Air fuel mixture, it is coming from the outside or the carburetor side. This is the piston is moving from the TDC to BDC condition. Exhaust valve, during that condition, it is the close, shut off. And again, when the moving from the BDC to TDC, and the piston is moved from the BDC to TDC, both valve are the close, and the compression of the mixture rate is taking place. And when the piston is at the topmost condition, and the spark plug which are operating in this time, both valve are the closed, and this time also the spark plug is operating, and the sparking is done at the when the piston is the topmost condition, and the sparking of the mixture is taking place, where the combustion process is initiated. Combustion process initiate होगी और gases के force से piston TDC से BDC की ओर move करेगा. And the finally exhaust stroke, where the exhaust valve is open and the intake valve is closed, gases will force out through this valve to the atmosphere when the piston is moving from the BDC to TDC. This is the condition and the operation occurring in the Otto cycle. It is called the working of also 4-stroke petrol engine or the 2-stroke petrol engine. In the 4-stroke petrol engine, there are the separating process done in the separating stroke. But in the case of the 2-stroke engine, two processes are the taking place at the 1 strokes. So this is the PV diagram where all the processes are the taking place. 1 to 2, this is called the isentropic compression, where the compression it is taking place. 2 to 3, this is the constant volume heat addition, where the combustion of the fuel it is taking place in the side of the engine cylinder, which is also called the IC engine. Combustion it is taking of the constant volume, and when the combustion process is completed, the isentropic expansion it is process of the 3 to 4 describing in the diagram PV, and the 4 to 1, that is the exhausting of the gases it is done at the outermost condition, where the gases are flowing at the atmosphere at the constant volume process. This is the TDC condition where the piston at the topmost condition. This is the BDC condition where the piston is at the bottom dead condition. So where the heat is supplied and where the heat is rejected. So heat is supplied, this is the process. This is the constant volume heat addition, 2 to 3 process. 4 to 1 where the heat is rejected, that is also constant volume heat reaction process. And the isentropic compression where the compression it is done, that is called a 1 to 2 process where the piston is moving from the BDC to TDC, and the isentropic expansion where the piston is moving from the 3 to 4. And after the sparking of the where the combustion is taking place, and the force of the gases which are circulated the piston from the TDC condition to the BDC condition. This is the actual PV diagram where the what is actual happening here when the intake valve is open and the ignition is done not at exactly at the topmost condition. Exhaust valve it is open before the going into the bottom dead center. It is not done it is not done at the topmost condition. Expansion it is the gases expanded in the very isentropically manner. Compression it is done at the isentropic compression it is taking place, and the compression it is not a compression of the expansion which are going into the isentropically manner. तो आइडियल साइकिल में कभी भी जरूरी नहीं कि ये सारी प्रोसेस आपकी कांस्टेंट वॉल्यूम या कांस्टेंट प्रेशर की या आइसेंट्रोपिकली होती है. इट इज नॉट फॉलो द thermodynamic rule or ideal gas process. These are differently going into the different manner where it is exactly happening in the engine cylinder, and the actual process it is the taking place in the engine cylinder, and the suction it is taking place of the lowest pressure condition. Exhaust is taking place the uppermost condition or the most of the high pressure. It is taking place in the PV diagram. It is depicted. The TDC condition, this is the condition where the piston top dead center condition. BDC is where the piston at the bottom dead center condition. These are process or the Otto cycle which are already discussed in the previous diagram 1 to 2, that is called isentropic compression, where the pressure and temperature both are increasing, volume will decrease. Constant volume heat addition where the volume remaining the constant but the pressure will increase and the temperature will also increase. Isentropic expansion after the sparking and the combustion process, the temperature and the pressure will reduce but the volume remains increases. Constant volume heat reaction where the volume remains the constant, pressure and temperature both will decreases. This is the description 1 to 2 process isentropic compression जो आपको यहाँ पे दिख रहा है P1 P2 ratio it is the equal to V2 by V1 to the power of n. T1 upon T2 that is the power of n upon n minus 1. Similarly, constant volume heat addition, this is the heat supply formula mCV T3 minus of T2. Isentropic expansion, it is the formula P3 by P4 is equal to V4 by V3 power n, and the upon is equal to T3 upon T4 to the power of n upon n minus 1. 4 to 1 constant volume heat reaction process where the constant volume heat reaction process is taking place and the exhaust gas is going to the atmosphere mCV T4 minus of T1. This is the thermal efficiency of the Otto cycle already discussed in the Carnot case. The thermal efficiency, it is the ratio of the W net upon the heat supply, and the W net is equal to the Q net. Q net is equal to the Q in minus of the Q out upon Q in, 1 minus of the Q out by the Q in. So Q in जो था that is the heat supply, Q out means आपका heat reaction. This is called a heat supply QS and this is called a QR heat reaction. Apply first law close to the process 2 to 3 and the volume remaining the constant. This is the formula. Because of the work done is 0. So there is a chances of the heat supply. It is represented in the here in the equation when putting the 2 to 3 mcb T3 minus of T2. This is the formula for the heat supply. Constant volume heat addition taking place. Apply first law closed system process 4 to 1 where the volume remaining the constant again and the constant specific heat is it is represented by where the net heat is reacted to the or heat is reacted into the form of the exhaust gases which are the flow into the atmosphere. Formula it is mcb T1 minus of T4. Work done is 0. This is 0. This is the formula Q out is equal to mcb T4 minus of T1 and the thermal efficiency becomes 1 minus of the Q out by the Q in. This is the 1 minus mcb T4 minus of T1 upon mcb T3 minus of T2. This is the formula for the thermal efficiency. After simplification, mcb cancelled out in the previous slide. This is the thermal efficiency formula 1 minus of the T4 minus of T1, T3 minus of T2. And after the simplification, when the T1 it is taking out of the top side T4 by T1 minus of 1, T2 it is from the bottom side T3 by T2 minus of the 1. Recall the process 1, 2 and 3, 4 for the isentropic. So for the process will be simplification. Then T2 by T1 is equal to V1 by V2 power of K1 minus of 1. It is also N. It is also represented by the gamma. कई जगह आपको K मिलेगा, कई जगह gamma मिलेगा, कई जगह N मिलेगा. So depending on the type of the book, type of the writer, depending on the this matter, T3 by T4 is equal to V4 by V3 to the power of K minus of 1. And these are the because of the constant volume process are taking place. V1 is equal to V4. 4 to 1 process, and similarly the process V2 is equal to V3. So that's why these are the equation are equal, and the T2 by T1 is equal to, can we write T3 by T4 and T4 by T1 is equal to T3 by T2. जब इसको यहाँ पे देखेंगे तो these are the cancelled out up and down side. So that's why the formula will reduce in the next slide. This is the formula of thermal efficiency 1 minus of the T1 upon T2. And the since the process 1 to 2 is isentropically, it is represented is here. T2 by T1 is equal to V1 by V2 to power of K1 minus of 1. Similarly, it is the formula which is represented and obtained the thermal efficiency formula of the Otto cycle 1 minus of 1 upon compression ratio ki power, that is the K minus of 1 or gamma minus 1. So these are the thermal efficiency formula or the derivation, where the compression ratio it is represented by the V1 by V2. V1 is the maximum volume, V2 is called the minimum volume. So it is the formula or derived thermal efficiency derivation of the Otto cycle. It is represented by this formula, and this is the graph where the showing the how much amount of the compression ratio it will be increased for the increasing of the thermal efficiency. तो ऐसा जरूरी नहीं कि कंप्रेशन रेशियो आप बढ़ाते जाएंगे तो थर्मल एफिशिएंसी बढ़ती जाएगी. इट इज अ सैचुरेशन पॉइंट वेयर द कंप्रेशन रेशियो इट इज ऑफ द लिमिट वेयर द थर्मल एफिशिएंसी इट विल बी इंक्रीज not much more because of the metal point of view. Efficiency will not increase further, and so that's why the limitation of the compression ratio in the Otto cycle or the petrol engine cycle, that is of 6 to 10. So thank you for the today lecture. If you have any doubt, please ask me.